Okay, here we go. Today's lesson, we're going to talk about an infinite geometric series. We're going to start and get a little philosophical on you. It says, how is it possible to find the sum of an infinite series? If you think about that, it really doesn't make sense. Most people think if you just add more numbers together, your sum should just get what? Bigger and bigger and bigger. It should blow up. It should go to infinity. I get it. Makes sense. So here's a little example called Zeno's paradox. It says a man standing in a room cannot walk to the wall on the other side. In order to do so, he would first have to go half the distance, then half the remaining distance, and then again half of what still remains. It says this process can always be continued and can never be ended. Of course, we know that if we wanted to, we could just boogie across the room here and touch the wall on the other side, no problem. Okay, so what that suggests is that perhaps the total distance can be expressed as the sum of infinitely many smaller distances, as follows. So what did Zeno do first? He walked halfway. Okay, so he went, say just for the sake of argument, the room was 1 unit long. Okay, a mile, a kilometer, whatever. He walked half the distance. And then he walked half of what remains. What's half of a half? Okay, then he walks half of what remains again. What's half of a quarter? An eighth, and then he walked a 16th, and then a 32nd, and then a 64th, and then 1/128, and so on and so forth. Okay? What would happen if I start to add all of these terms up? We should be able to get the total distance, which we'll say is 1 unit. And in order to make sense of it, let's look at it. Like, if I want the sum of the first term, if that's only this term right here, okay, that would be 0.5 or 1/2. What if I wanted the sum of the first two terms? What's a half plus a quarter? Okay, it would be 2 quarters plus 1 quarter, and that would give me 3 quarters, or 0.75. A half plus a quarter plus an eighth. Okay, that would be 4/8 plus 2/8 plus 1/8, 7/8. Okay, what do you notice about these sums? The more terms I add, the sum's going from 0.5 to 0.75 to 0.875 to 0.9375. It's getting closer and closer to what? Yeah, it's converging on 1. Look at the sum of the first 5 terms. I got 0.96875. Now, is it ever going to go beyond 1? No. So what do we say? Is it converging on 1 or diverging? Converging. Look at, here's the sum of the first 10. Here's the sum of the first 16 terms. And you can see as we add more and more terms, the partial sums become closer and closer to 1. In fact, by making n large enough, we can make the partial sums, or the partial sum, Sn, as close as we like to the number 1. And we can say the following. The limit as n approaches infinity, Sn equals 1. Okay? So it is possible, by that logic, to find the sum of an infinite series. Now, it has to be a special type of series. It says if the infinite sequence of partial sums has a limit, as in the previous example, then we say the sum of the series is L, and we write. Okay? Notice we're using sigma to represent the sum of the terms in the series. And we're going from n equals 1 to what? Infinity. If a series has a sum, we say it's convergent. If it doesn't have a sum, it is divergent. So it's the same rules as yesterday. If it had a limit, it was convergent. If it didn't have a limit, it was divergent. If it has a sum, it's convergent. No sum, divergent. These are the types of series, or this is the type of series that you can find the sum of. It has to be geometric. So what do we mean by geometric? It has a common ratio. So if it's arithmetic, no good. Okay, it doesn't have a sum. It would be divergent. But what do you notice? What's the rule in order for it to have a sum? The R value has to be what? How do I read this? Okay, between -1 and +1, yes. Or Meredith said greater than -1, R is less than 1. Can it equal -1? Can it equal +1? No. Look back to this example we were talking about. What was my A value in this series or this sequence? 1/2. What do I do to 1/2 to get a quarter? A quarter to get an eighth? I multiply by 1/2. So my R value is also 1/2. General term would be 1/2 times 1/2 to the power of n minus 1. That's how you find the general term of a geometric sequence. And what do you do when you multiply powers with the same base? You add the exponents. I write the base down again. What would the base be? Not a quarter, 1/2, right? We don't multiply them, you just write it down again. And then you add these exponents. What is 1 plus n minus 1? Just an n. 1 to the power of n is just going to be a 1. So that's where they're getting this. Now tell me this. We know because it has an R value that it's what type? It's geometric. So it meets criteria number 1. It has to be a geometric series in order to have a sum. What about its R value? The R value has to be between -1 and +1. Does 0.5 or 1/2 qualify? Yes. So it met both criteria, therefore it had a sum. Okay? And if we used this formula right here, we could have solved that sum. What was the A value in that previous example? What was the R value? Also 1/2. If I try and find the sum, we know that the sum was what? We look back, what did this all add up to? It all added up to 1. Okay? Let's make sure or prove that this formula works. Sn is going to equal 1/2. I'll fill in my A value. Over 1 minus 1/2. How do you subtract fractions? Let's do that first. You get a common denominator. So the numerator here is still going to be 1/2. But down here, I would have 2/2 minus 1/2. Agreed? 1/1 or 1 whole is 2/2. If I subtract 1/2, what am I left with? 1/2. What's 1/2 divided by 1/2? It's 1, right? Like most people can make sense of that. They know anything divided by itself is 1. Proofs in the pudding. If you didn't know or didn't think that a half divided by a half is 1, you could use your knowledge of dividing fractions. How do you divide fractions? Multiply by the reciprocal. What's the reciprocal of 1 over 2? 2 over 1. This would be 2 over 2, top by top, bottom by bottom, which is 1. Either way, I'm getting 1. So remember the rule. When you divide fractions, you keep, change, flip. So I keep the 1/2, change division to multiplication, flip the 1/2 to 2 over 1. Fair enough? Couple of examples to work through. And do you have these? Yeah. Cool. All right, why not take a minute right now? Or let's do the first one together, and then I'll give you a minute to try and figure the others. All right, first of all, what type of sequence do I have in the first example? It's geometric. It's got an A value of 4. That's T1, the first term. What's the R value? A half. 2 divided by 4, 1 divided by 2, a half divided by 1, a quarter divided by a half. Okay, just to prove, a quarter divided by a half. We keep, we change, we flip. That gives me 2 over 4, or 1/2. Okay, so I know it's geometric, wicked. So I know it could potentially have a sum. Is the R value between -1 and +1? Yes. How do I know when to use this formula versus the old formula? Remember when we were talking the sum of a geometric series, we did this. That's what we used to use. So why now, or when, do I use this formula? Not necessarily, not just when the R value is between -1 and +1, but that tells me that I could use this formula. But remember, this is for finding an infinite, or the sum of an infinite number of terms. This one was for finding an indicated sum. So you would use this one if it said find S10, no matter if R was 2 or if R was a half. Okay, so don't assume that just because your R value is between -1 and +1, you have to use this formula. If I said to you to find S10, okay, I would use this formula right here. I'd fill a 10 in for N, a 4 in for A, a half in for R, and that would become a 10. So how do I know that like this is infinite? It says find Sn for the following infinite geometric series. So it's saying find Sn. It's not saying find S5 or S10 or S20. But how do I know that this series continues on forever? The 3 dots indicate that it's infinite. And I can find the sum of an infinite geometric series so long as my R value is greater than -1 but less than +1. So here we go. This is going to equal 4 divided by 1 minus a half. We know that 1 minus a half is what? It's a half. We did that on the previous page. 2 over 2 minus 1 over 2, this is going to become 1 over 2. Now, what's the rule when you divide by a fraction? That's right. So we're going to keep the 4. We're going to change the division to multiplication, and we're going to flip this. 1 over 2 should become what? 2 over 1, which is really just 2. So what's the sum going to equal? 8. And just for proof, look at this. S1 would be 4. The sum of the first two, 4 and 2 is 6. The sum of the first three, 7. 4, 2, and 1. Then I'd get 7.5. I'd get 7.75. You can tell that that is converging on 8. It has a sum. What about this next one? Why is it not going to work out? You just looked at that and bam, knew the answer. The R value is greater than 1. Okay? In this particular case, A is 3. First term, T1 is 3. The R value is 6. Sorry. The R value is 6 divided by 3. 12 divided by 6. 24 divided by 12. The R value would be 2. Once again, it's infinite. It's not asking for S10 or S12. It wants Sn. But I can say there is no sum, or that it is divergent, because the R value is greater than 1. 2 would not fall, where are we looking here? Between -1 and +1. Fair? And I think you can see that if I add 3 and 6, I get 9. If I add 3, 6, and 12, I get 21. This would give me 36, 42, 45. The more terms I add, the bigger the sum I get. Some people think that they could do this. 3 over 1 minus 2. 3 over -1. That don't make no sense. Right? Like it can't equal -3. Check it. Why does this not make sense? Because the R value is too big. So again, just to reiterate, this is for an infinite. You can only use this one if it's an infinite sum. And it only works if your R value is greater than -1 but less than +1. You could still have an R value of 1/2 and use this formula. The question would just ask you to find the sum of the first 5 terms. Okay? Last question before you go on to your worksheet. What is going on here? Sigma notation. What does sigma mean? Find the sum. That's right. Okay. What do we have after the sigma notation? What does this, all of this represent? That's the general term. Now, maybe you can notice what your A value and what your R value are in that particular question, because it takes the form A times R to the power of n minus 1. Anyone see the A value? A would be 3. What's the R value? R is 1/4. Now, this one doesn't have a ... but it says explicitly on the top, start at 1, end at infinity. Now, I don't want you to just add an infinite number of terms, like we'd be here forever. You can't do that. Or wait, yes, we can do that. What formula would I use? That's right. Sn is going to equal A divided by 1 minus R. Sn is going to equal 3 divided by 1 minus 1/4. Sn is going to equal 3. What's 1 minus a quarter? That's right. 4 over 4 minus 1 over 4 would be 3 over 4. How do you divide fractions? Keep, change, flip. Now, if you want to go top by top, 12, bottom by bottom, 3. 12 divided by 3 is 4. Some people would divide first. 3 divided by 3 is a 1. 1 times 4 would be 4. Now, suppose you didn't recognize this as being geometric. Everyone have that down? Yeah? Suppose you didn't recognize this as being geometric. Well, you could actually generate the first few terms and then pick out A, R that way. Like, what would the first term be? What would I fill in for an n value if I want the first term? A 1. So I'd have 3 times a quarter. What's 1 minus 1? Then I'd have 3 times 1, because a quarter to the power of 0, or anything to the power of 0, is what? It's a 1. I'm going to add 3 times a quarter. What would the second term be? What's 2 minus 1? I'd have 3 times a quarter. A quarter to the first is 1 quarter. 3 times a quarter is 3 quarters. Why am I putting a plus sign between them? It's a series, the sum of plus. The next term would be 3 times a quarter. Look at this is term 3, right? Term 1, term 2, term 3. So what am I filling in for the n value? A 3. What's 3 minus 1? So I have 3 times a 16th. 1 squared is 1, 4 squared is 16. I have 3/16. Easy to see that A is 3, yes? How would you get R? You would divide. You would go 3 quarters divided by 3. Keep, change, flip. That would give me 3/12 or 1/4. If you did the same thing, 3/16 divided by 3 quarters would become 3/16 times 4/3. The 3's would cancel. And 4/16 would reduce to 1 quarter as well. So that is another way to get your A and R value, to just actually generate the series. Or the first 3 terms, that's probably lots. Your job now is to do number 1 and number 2 from your worksheet.